Alright, as I, the wild, crazy Mr. O, is back. It is Unit 5. We are now up to Lesson 3, and we're going to learn the next algebraic method for solving systems of equations. And in this one, it's called the elimination method. We will see a couple of those in one, and we're going to get some practice in there because we think you guys will need all those down there. But the bottom line is you did this one as well last year in 8th grade, and our objective in this lesson is to solve a system of equation using the elimination method. So let's go take a look at example 1. All right, for example 1, here we go. Once again, they tell you that the solution is 1 comma 5, and we're going to plug that into both equations to make sure they work. So if I do the first one right here, and I've got 4 times x is 1, plus 2 times y is 5, that's supposed to equal 14. Well, 4 times 1 is 4, 2 plus times 5 is 10, and yes, 14 equals 14. But once again, we got to make sure it works in both. Sometimes it does, sometimes it doesn't. And the second equation right here, I would plug in my 1 is 1 minus y is 5 equal to negative 4. And sure enough, 1 minus 5 is negative 4. So it does indeed work in both. Well, they want you to explore here a little bit, and instead of doing the substitution method here, which neither one is really, if you take a look at it, neither one has x equals or y equals anything, does it? You'd have to move something to the other side to do that. So you're going to explore a different algebraic method, and it's called the elimination method here. And they want you actually to try something here, and you guys learned last year elimination by adding first. So they want us to take this and sum the two equations, so they want us to add them. Well, if I add them, I get 5x, and then 2y minus a y is plus 1y, equals, and then 14 and a minus 4 make 10. Well, last year you should have done some, and when you added sometimes, something fell out. Well, nothing fell out right here, so we have to kind of explore where they're trying to get at this, and you'll see in a moment on the next page. But they want to know, hey, if I add the two together, does this thing still work, this answer? Well, let's try it out. I'll pick a different color just so you can see. We're going to put 5 times, and we're going to put a 1 in, plus 5. Does that equal 10? Well, you get 5 plus 5, 10. And sure enough, 10 equals 10. So it does work. So yes, indeed, bottom line here is that just because I added the two systems equation, the solution is still good with them. And it's kind of like that commutative property all tied in there. But we're going to keep going on in this example 1. There's more to this yet. All right, now we're going to be into part C of this question, and they want us actually to multiply the second equation by 2 and check to make sure it still works. So, our second equation was x minus y, and that was equal to a negative 4. And our job is to multiply the second equation by 2. So that would be the entire thing, you got to remember. Everybody gets multiplied by 2. So you will get 2x, then you will get minus 2y equals negative 8. And they want us, does this thing still work? So, well, let's take this. You got to take this problem and go 2 times, now we're going to plug 1 in for x again, minus 2 times y is 5, and see if that's still equal to, in this case, negative 8. So you get a 2 minus 10. Does that equal negative 8? And sure enough, negative 8 equals negative 8. So yes, still works. Okay, bottom line. Now in part D, or part D, yes, they want us to take the first equation and take our second equation, which we just figured out up here, and we're going to put that one in right there, and we're going to add the two. Well, if you take 4x plus 6x here, or 2x, you get 6x. Watch what happens right here. What's a 2y and a minus y? They cancel. Gone. And 14 and a negative 8 makes 6. Last step, divide by 6, and x is equal to 1. Once again, we're trying to figure out everything. So now we got to take one of the original equations. Doesn't matter which one, whichever one you want. If you want the original one where we had x minus y equals negative 4, and we know that x is equal to 1, we can plug that in. So 1 minus y equals negative 4. And so this is the part E that we're actually doing now here. Once you found x, this is what we're going to do. We plug it back in. I would move the 1 over, personally. You get negative y equals negative 5. And last step, remember, that's an unwritten 1 there. So divide by a negative 1, divide by a negative 1, and y turns out to be positive 5. So what happens once you figure out the x? You plug it back in to get the y, and we have a solution. And our solution is 1, 5. Once again, I would check these two. If you want to use a graphing calculator, you got to get them both in y equals form. If you want to plug the 1, 5 in, that's fine. They already told us in this equation, so I'm not going to worry about checking because we already know it does work in both the originals. But when they don't tell you to, that's what you do. So bottom line here is you just learned elimination also by addition. All right, now we're on exercise 2. I want you to try part A on your own first. So pause the video, throw in the 3, negative 1 into the two equations, and make sure it does work in both, okay? All right, now that you paused and did it, hopefully you found that it did work on both. If not, please ask us in class, and we'll go over it for you in that, but it should not have been a big deal to do. Part B asks you to take the 3, negative 1 and figure out, hey, is this actually a solution for this system also, and think about it without even graphing or doing substitution or anything. Well, I take a look at it, and I take a look here, and this one here, the first equation was 4x minus 3y equals 15. Do you notice how if you double 4x, you get 8x? And if you double minus 3y, you get minus 6y. And if you double 15, you get 30. So that was doubled. So bottom line is we were doubled. And if you take a look at this one, that's the triple of the other one. Okay? So bottom line is, yeah, the equation, remember we multiplied in the first exercise by a certain constant, or that, and your equation stays the same. All right? So the bottom line is it will work, and if you don't believe me, give it a try. We're going to go down to C, though, now, and we're going to actually take a look at this equation in other ways. So they actually said that it was 8x, and it was minus 6y equals 30. And they said take the 9x and plus 6y, and that was equal to 21. And now let's see if we can do elimination. Well, I know we did a multiplication first on the one, and these are actually multiplied too, but they're all lined up here. What will fall out if we actually add them together? And you are correct if you said that the y's would cancel. So if I cancel the y's, you add together, you get 17x here, and that's going to equal 51. And then you divide by 17, both sides, and x will turn out to be 3. So there's part of our answer, 3. Now, where's the rest of it? Well, once again, you got to plug it back in. Take the 3 into either one. So I'll take the first one. I'll do 8 times 3 minus 6y has to equal 30. And I will get 24 minus 6y equals 30. So if I move the 24 over, minus 24 on both sides, you will get a negative 6y equals positive 6. Divide by negative 6, and y is equal to negative 1. So that's the other half of our answer here, and that is your solution. Good to go. Once again, you can check multiple ways. The easiest would be to throw the 3, negative 1 in back into both. We already know it's been working all the way along, so I'm not going to do that. All right, let's move on with this question. All right, last question is exercise 3, and it basically just says solve the equation by the elimination method. Well, once again, I try right away to see if I can add something. But if I add, you won't get the x's falling out. You won't get the y's fall out. So adding by elimination is not going to work. So I would go by the multiplication. We're going to actually learn another one with the multiplication where you can both lines. But bottom line here is I take a look at this, and there's nothing times 4 that'll give me 3 nicely, or 3 times 4. But there is a number times 2 here to get me the 6. And as I go and I do this, I would actually go and I put a set of parentheses around this, and I would actually multiply by 3. But 3 times 2 gives me 6x, and 6x and 6x is not going to fall out. So I need the opposite sign as well. So if I actually do multiply by negative 3, here's my two new equations. I'll draw it over here. So I would get a negative 6x. I would then get a negative 12y. And remember, you got to distribute all the way a minus 6 on the other side. At the same time, I'm not touching the second equation. I'm leaving it alone at 6x plus 3y equals negative 3. Now when I go to add, okay, you will see that the x's fall out. And I combine these two, I'll get a negative 9y equals a negative 9. Divide by negative 9 both sides. And y turns out to be 1. So half my answer, the y part, is 1. So I can put in the second piece there. Once again, I'm not done because I got to find x and y. So I got to plug it back into one of the originals. So I'm going to go back up here. I kind of like the first one, so I'll take the 2x plus 4 times y we now know is 1 equals 2. Nice numbers, no negatives. It looks great. 2x plus 4 equals 2. Bring the 4 to the other side by subtracting it, or adding a negative, whichever way you want to look at it. And 2x equals negative 2. Almost there. Get rid of the 2 by division, and x turns out to be a negative 1. So my solution for this one is negative 1, 1. There's my answer. Once again, check it by plugging it back into both. That's elimination. You can multiply by a certain piece. You can add and see if they fall out. You can subtract. You can actually learn to multiply both lines. We're going to do more of this again tomorrow. Give some more practice on it. Write a nice WSQ and you have any questions ready, and we're ready to roll and move on to the next lesson then. Thanks.